So what we'll do today, just first review the first three tasks that we have completed for yesterday's experiment. Right? So just recall the three tasks. The first one is the so-called beauty context. And you complete this task twice. The first one is just your personal preferences. And the second one is that you are incentivized. You will try to match the preference or the choice of another participant in the same classroom. So anyone want to share what is your reasoning behind this task? Has anyone changed the choices between the first and the second task? Anyone?
I changed my choice.
It's Louis.
Yes.
Yeah, good. Why you change your choice? Maybe you want to share with us.
Because I was attracted to the smile out of the third one. And I don't know if it's factual or not, but my assumption was that there were more men in the class, and I would assume that they would be more attracted to number 4.
Okay, that's a good reasoning. But I mean, this reasoning is quite important. It actually illustrates the difference between individual decision making and strategic decision making. For individual decision making, you don't need to care about the preferences or the behavior of others. But when you come to the second task, you have to consider what is the most popular choices there, right? You have to consider what are the likely choices by others in order to win the award. So here are the distributions of the result across the 2 rounds. I mean, it's actually surprising to me that not a lot of you have changed the choices. I ran this experiment for this MBA students and also for some other international students. A lot of them have actually changed their choices. And actually, the most common change is changed to number 4. Right? So for a lot of people, their personal preferences is some other phases other than this Scarlett Johansson. But when you are asked to indicate your choice such that the matching of another's choice would actually give you a reward, that would actually change people's choices. Okay, so what is going on there then? Because when you think about the second task, where you try to match the choice of another person, what matters is not what you think anymore. In the first one, you just indicate your personal preferences. But when you move to the second task, you need to think about what most people think that most others will think. So here is not only the most popular choice or the most popular phase by the other people. It's not their inherent preferences. It's also second order belief, what they believe that other people or what they believe that most other people would choose. Okay, so here, this is the idea of the focal point. Louis actually mentioned that in the previous class yesterday. The aim in this second task involves strategic interdependence and strategic decision making. So that means you're not trying to make any absolute judgment of beauty, but to find a focal point of this process of thinking. Okay, so here I give you the formal definition of focal point. So this focal point is a quite important concept in coordination game, which we'll elaborate on. So the focal point is just people's expectation of what others expect them to expect to be expected to do. Okay, so this is a very involved definition of focal point. So there are other simpler definitions. Basically people's common expectation of what most other people would do. I put this complicated and involved definition to show that focal point is actually about higher order of belief. That is not very simple, very easy to develop what is the focal point in some situations, right? So this beauty context, this task, will be able to help us understand why stock price can deviate greatly from its fundamental value. So I don't know whether you have followed the news during the pandemic. The stock price for GameStop, for example, roses dramatically. It's just basically the Wall Street has a really low rating of GameStop, but the nerd who are playing the computer games, they think you don't know anything about the game. So all the nerds, they actually try to collectively purchase this corresponding stock of GameStop, that should actually drive up the stock, right? So that's the idea here is that the hot stock is not necessarily the one with the highest fundamental value. Okay, fundamental value is like the future expectations of earnings, right? To the current stock. So the hot stock, which rise in price, is not necessarily the one with the highest fundamental value. Right? Sometimes it is, and most of the time it is the one with highest fundamental value, but not necessarily the case. It could be the one that everyone thinks that everyone else think is the hot stock. So here is like a self-fulfilling prophecy. If everyone think that stock would rise in price, it would actually rise, right? That's the idea of a beauty contest. So here is a quote by the famous economist John Maynard Keynes. What is the reasoning behind the beauty contest? So here, maybe we can just quickly go through this quote. It is not a case of choosing those faces that, to the best of one's judgment, are really the prettiest, nor even those that average opinion genuinely thinks the prettiest. We have reached the third degree where we devote our intelligence to anticipate what average opinion expects the average opinion to be. And there are some, I believe, who practice the fourth, fifth, or higher degree. Okay, so that is the complication behind this simple beauty contest game. Right? So that is game one. Now, game two is actually simpler. It's called a meeting place and time. You and another person need to meet somewhere tomorrow in Odense, and you have no way to communicate. So you need to find the common time and place for your meeting so that you will be able to successfully meet the other person, right? So again, I want to ask some of you to share how you come up with the time and location for this task. If anyone want to share.
I maybe overcomplicated a bit because you decided to make us agree to meet at a place the day after where we would have a place that we would actually meet somewhere in Odense. So I decided to expect that the focal point of anyone in the class would be the class at the time where the class was at. So STU at 15.
That's actually a good reasoning, right? So here we again come back to the idea of focal point. What is a focal to a group of people actually depends on the experience, the convention of this particular group. So this same task was actually asked among New Yorkers in New York. And the most common answer provided by the New Yorker is actually the Grand Central Station, the train station, the central train station at noon. Okay, so without any further information, noon seems to be like a focal point, to be like, you know, somewhere in the middle of the day, and the Grand Central Station is probably the most popular place in New York. So if you ask random person in New York, then at noon, Grand Central Station is the focal point, and actually more than 80% of the people would actually choose that time and location, and they would be able to successfully meet each other. And again, if you ask a random person in Odense, it is likely that the people would say noon and at the train station. Okay, so it's just focal point of people's expectation. Now, let's take a look at your responses. So here, a lot of you actually have chosen noon. I mean, this is very special to our class because for our class, for yesterday, the meeting time is noon. Okay, so there are two meanings behind this noon. Now, it could be the starting time of class on that day, and it could also be the middle of day. If there's no other additional information, that's likely to the point that you want to meet with each other. And here we see a divide of answers. Almost half of you have chosen, more than half of you have chosen STU or the university. okay? Because that's where the class meet. And the other slightly less than half actually choose the train station, okay? So it seems that when we ask this same task among the class, it's actually making it more difficult because for this particular class, we have maybe divergent focal point, right? So one focal point is the class time and class location. And the other one is, general, a common person in Odense. For a common person in Odense, then is likely to be meeting in the train station, and at noon, maybe a focal point, right? So there are also some other times that indicated. Maybe some of you, if you want to share why you have chosen this particular time. So 8 o'clock at the university, 8 is also something focal because that's actually usually the first class that starts, okay? And sometimes we do see people put like 12:15 or 15:15 because, that's actually the complication of the academic culture system in Denmark. When we say the class is from 12 to 2, is actually 12:15 to 2, right? Because the class usually start at a quarter after the hour. So that's actually make this coordination, or this make this focal point more complicated. When I ask this question towards the MBA students, actually a lot of them put 12:15 instead of 12 because that's the time for the for class to start. Okay. Anyone want to comment on this task, this meeting time and location? No, that's back to the silence of online class. Yes, go ahead.
I mainly have a point that I think you should do it a day where, or you should like emphasize whether or not, like, with the class. I don't think you should have a class the day after when you ask us to meet there somewhere that day. I think that muddies the result.
Yeah, that's true. The day after, right? So because the day after, I like your reasoning. I think if I were you, I would choose the same time and the location, because on the next day we happen to have a class, and that's actually quite focal. But if I randomly ask the day, right? So ask towards the weekend, probably you would choose noon and SDU or the central station, right? So here, the way of asking and also this expectation matters a lot, right? So ask which specific day, on a specific day you may have different focal point, different expectation, and that will change the answer, right? So that illustrate the complication of this question, right? Yeah, thanks for the comments. Any additional comments before we move on? No? Okay. So let's try to see what we could learn from this meeting place and time. Again, here, what matters is not where or when to meet. You just want the two persons to go to the same place and the time, right? So no one have a particular preferences for a particular time or particular place. You just want the place and the time to be the same. So here, again, focal point is actually quite important. And the focal points are usually determined by culture, tradition, convention, and they played an important role in choosing the place and time. So for a particular group of people, usually you have the particular culture, right? So for our class, we have the focal point of the class time and the class location. But in general, different countries, different area, different location, they would have some tradition and conventions. So here, for example, some countries choose to drive on the right as a convention. Some choose to drive on the left. And some countries choose to use the color red to indicate the rising stock market, right? So in East Asian countries like China, Japan, when the stock market price rise, you use red color to indicate that. But in other countries, in Denmark, in the United States, in most of the European countries, they actually choose green to indicate rising stock price, right? There's no right or wrong in those choices. It's just determined by the convention. For example, the Chinese culture, red is good, represent happiness. Usually during the festival, it's decorated in red. So that's why they choose red as indicating some good news, right? But in other countries, green means that green light means that you can go ahead. That means some good news. So that's why they have chosen green as indicating rising stock price, the good news. So there's no right or wrong. It's just a convention. So here is an illustration of distributions of the which direction, which way you are driving for the traffic. And sometimes, you know, the convention could be determined by law. Okay. And most of the time it's determined by social norms. Sometimes we do see that the laws can actually try to override the convention. But you see the power of convention is so strong that sometimes when there's a conflict between formal legal system, what is dictated by law, and what is prescribed by social norms sometimes could win, right? So here is a really chaotic picture that is that was taken on the day where the traffic in Sweden switched from the left to the right. You know that on that specific day, by the requirement of a law, you should drive on the right. But people are not used to this new way of driving yet. So they follow their convention, right? So when there's a conflict between law and convention, sometimes the convention would win, at least in the short run. Okay. In the long run, of course, that the legal system, what is prescribed by law, would eventually override the corresponding social norms. Okay, so that's what we could learn from the second game. Now the guess number game. Again, let's just try to recall. In this game, you need to pick a number between 0 and 100 inclusive. And after everyone has chosen this number, then we calculate the average. And the number indicated by all of you, who is closest to the 2/3 of the average, would win this award. Right? For example, if the average of all the numbers that you have indicated is 60, then 40 would be the correct number, or the number that would bring you the award. Okay. Now, if anyone want to share the reasoning behind this, now is the time. But here, let me show you the results of your choices. Okay, we do see that the numbers are decreasing. And this is consistent with this learning directions theory just presented by Jonas and Mikkel. But we do see something, some behavior very bizarre here. So after first round, you probably know that the correct number is 20 something, right? Some people, they actually indicated a number greater than the target number, but we see five of the participants actually indicate a higher number. I don't know whether you just try to play a prank or just randomly chose a number that you don't care about the result, but this is not something, some behavior that is consistent with the learning direction theory. But if any one of you want to share about these several choices, you're welcome to do so. But in general, we do see the numbers indicated are actually decreasing. Okay. Now, let's just have some game theoretical analysis of this game. So this game is actually called a Keynesian's beauty context. You can read the history of why this is called a Keynesian's beauty context. I mean, this is actually related to the game one that we talk about, which we call it the beauty context, because here the common expectation is actually quite important for you to determine which is the successful winning target, right? Now, the game theoretical analysis that you can derive for this game is can show that 0 is the only Nash equilibrium, right? We have not introduced the concept of Nash equilibrium. I know a lot of you have understand the concept of Nash equilibrium from game theory course, but 0 is the only Nash equilibrium. And the Nash equilibrium, it just indicate that rational players who expect others are also rational would always choose 0. Okay, so can any one of you tell me why 0 is the Nash equilibrium, or say by game theory is the predicted outcome? So no one seems smart to talk. I mean, let's just assume this situation. When everyone is choosing 0, then the winning number would be 0, right? So that's very easily derived. So in that case, if everyone is choosing 0, then no one would be willing to deviate from 0, meaning that you increase the number to 1 or 2. Because if you're choosing 0, given that everyone else is choosing 0, then you are splitting the award, right? But if you change your answers to 1, for example, I mean, the winning number is 0, and you will earn nothing, but the other participant will split the award, right? So that means if everyone reached the point that the choices are all 0, then no one will try to deviate from this number. So that's why 0 is in Nash equilibrium. And as you can, as it can be shown, it's actually the only Nash equilibrium, right? So that means if everyone is rational, they really think through this reasoning process for this guess number game, then and expect others are also rational in the sense that everyone else could also reason through this game, then everyone would choose 0. Okay, but as you can see here from the experimental results, 0 as a prediction really failed dramatically, right? So we do not see anyone of you have chosen the number 0. Okay, so this actually shows that not everyone is rational, and indeed choosing 0, which is the number predicted by Nash equilibrium, usually does not perform well. So none of the participants who participate in a similar game like this, choosing 0, would have won this award. Okay. Now let's just try to understand what is going on here, right? So if you look at this game, what number you want to indicate, you might assume that there are different types of players or different types of thinkers when they try to choose a number. So we could use this model of cognitive hierarchy to understand this game. So some of the players, some of the participants in this game, I mean, since it's just you need to choose a number between 0 and 100, I mean, they just consider it as a game, right? So since it's a game, why play it so seriously? Just randomly choose a number or choose your lucky number without thinking this process. So we call those type of players as level 0 player. They randomly choose a number. And then if you're a little bit more sophisticated, you think more deeply compared to level 0, then you assume that everyone else is level 0, and you try to best response to level 0 players. In this case, if everyone else are level 0, they will randomly choose a number. That means the mean of the number would be 50, and 2/3 of that would be 33. Okay, so this is telling us that if you are level 1 thinker, you will probably choose the number 33, and thinking that would bring you the award. And if you are more sophisticated than level 1, you are level 2, and you assume that everyone else is level 1, then you would best respond to level 1, right? So you will choose 2/3 of 33, and that is 22. Okay, and you can keep this process of reasoning. You have level 3, level 4, and to level K or level N. And also we can assume that there are sophisticated individuals. I mean, they have an estimate of distributions of different levels of thinkers, and they try to respond to this distribution of different thinkers. Okay. So here, for this guess number game, it is not enough to know what rational player would do. So if you are a rational player, assume other people are rational, you will choose the number 0. So here, the important thing is to need to know what would happen for the interaction of different types of boundedly rational individuals. Okay, maybe you're just very bounded rational, you choose a random number, or you just assume that other people choose a random number, you best respond to that, right? So here in this case, Sheldon and Penny, Sheldon can be considered as rational thinker in this game. He would probably choose 0. Penny would probably can be considered a level 0 thinker, just randomly choose a number. neither of these two type of players would play well in this game, because you need to have an estimation of other people's choice, other people's expectation, and best respond to that in order to win this award, right? So this game actually illustrates the complication of strategic interdependence. So you have seen the result of your own behavior. Let's look at the distribution of gases from another large-scale studies, which is the game that among these Financial Times readers, right? So this Financial Times magazine actually send out this invitation to the readers to provide the gases, and the winner will be able to win a very luxurious European vacation, provided to this actually run in the United States. And as you can see here, we see some distributions of players, and 33 is actually, this number has a really high frequency. I mean, this is actually consistent with this level 1 thinker, right? And 22 is level 2 thinker, also it has a really high frequency. But the winner of this is actually around 13. Okay, that's the number for this game, for this pool of participants. And we do have someone who are really rational. They are probably quite sophisticated, or think they are sophisticated, and also expect others to be sophisticated. They choose the number 0 or 1, but it's actually a little bit far away from the winning number, right? So here I can tell you that this reasoning process, right? So I can tell you that any number above 50 could be eliminated as the winning number. Or maybe the first process would be, I make this claim that any number above 66 should be eliminated, right? So you should never choose a number above 66. Why is that the case? Let's take the extreme. Suppose everyone chooses the number 100. The average is 100, and 2/3 of 100 is 66, right? So that means the number can never go above 66. So all the numbers above 66 are eliminated. So, and then we follow this reasoning process. If any number above 66 is eliminated, then any number above 44 will be eliminated, because if everyone chooses 66, then the average is 66, 2/3 of that is 44, right? So all the number above 44 is eliminated. And we follow this reasoning. Eventually, we would eliminate all the numbers above 1. So that's what rational thinkers would reason and reach the number 0. But as we can see here, it's actually too low for as the winning number. Okay, so here I have included a movie clip from this Princess Bride to show that this concept of cognitive hierarchy, right? So here, being too sophisticated usually is not a good idea, right? So what you need to do is just one level ahead of your opponents in order to win this game. So this is an old movie. So if you are interested, you can watch this movie clip on your own. For the sake of time, we just finished the discussion of guess number game. So what are some applications of this guess number game? So we can actually find a real-world parallel of timing game in financial market that can be make an analog to this guess number game. So think of the time at which investors choose to sell a rising stock as picking a number, right? And when many investors choose to sell, the stock crashes because the simple supply demand. When the supply, right? When every investor is trying to sell, then that means the supply of the stock is so high that will drive down the price. So the stock price will crash. And the timing of this crash is around the average number, the selling time chosen. And what the investors want to do is to sell a few days ahead of the crash, right? So that's you need to choose the good timing, right? So this time a few days ahead of crash can be considered as picking a number equal to P times the average number, right? But you don't want to be too ahead of this crashing time, because before the crash, the stocks still rise in price, and you want to sell as close as to the crash time, but not too close, because if you're too far away from the crashing time, you sell too early, you have not realized all the potential gain. But if you get too close and you reach the point of crash, then you lost all your investment. Okay, so that is the real world parallel of the guess number game. So what we could learn from all these three games, right? So in all these three games, what others do have a great impact on your payoff. And in order to make good decisions, you need to put yourself in others' shoes. So using the terms of psychology, you need to have a good theory of mind in order to perform well in these three games. Okay. So now let's take 10 minutes of break, and we'll get back to discuss games and some examples of games and the application of these games. Right. So see you in 10 minutes. All right, so let's get back to our discussion. So let's first introduce some basic concept related to game theory, in case that some of you have not taken the course in game theory. So what is a game? A game is actually a model. Right? It's a mathematical model of strategic situation in which players' payoff depends on their own and others' decision. Again, as I have mentioned, all models are wrong. A game is actually a model of a real life situation. It's actually stripped away some other factors, right? So it's not a perfect reflection of the reality, but some models are useful. And a lot of games are actually quite useful for us to understand the corresponding strategic situation. And a game consists of a set of players and a set of strategies or say actions, and then the payoffs for each player for each combination of strategies or actions. And given this game, we can show that all the games would have a Nash equilibrium, sometimes have more than one Nash equilibrium. And a Nash equilibrium is just a set of strategies, one strategy for each player, such that no one has incentive to deviate. Okay, so we have discussed that in the guess number game, the only Nash equilibrium is for everyone to choose 0, because in that case, no one of the players have any incentive to deviate, to change to another number. Okay, so now let's do some exercise to check whether you understand the concept of Nash equilibrium. Right? So here we have this original guess number game. So pick a number from 0 to 100, and suppose the average of all the chosen number is x. The one whose choice is closest to the 2/3 of x would win this award. So what is the Nash equilibrium for this game? As we mentioned, the Nash equilibrium is for everyone to choose 0. Okay, and now here we have another game. The one whose choice is closest to 1.1x would win an award. What is the Nash equilibrium for this game? Think about it and see whether you can come up with the number. I might ask some question like this in the exam, right? So make sure you understand how to solve this question. And if you are able to figure out the second one, what about the third one? The one whose choice is closest to 100 minus 2/3 of x would win an award. So for the second one, I can tell you the answer is 100. Okay, think about why that is the case and how to arrive at this number. Okay, and the third case, how shall we derive at the number? Okay, give you maybe 1 minute to think about this. And again, what we are trying to arrive at is the Nash equilibrium. And Nash equilibrium may not be a good predictor for the behavior, at least initially. Okay. But the reason why we want to study and introduce the concept of Nash equilibrium is because, I mean, first is a convergent point, meaning that when everyone has chosen this Nash equilibrium, then it's unlikely that anyone would change to another strategy, okay, if they're trying to maximize their payoff. And also, if we allow experience to come into play, I mean, it's likely that the behavior would converge to Nash equilibrium. Let's go back and look at the slides of the guess number game, right? So here we have played this game for 3 rounds, and we see that the numbers indicated by the participant, by you, are actually decreasing across rounds. And we could actually imagine if we allow this game to be played, for example, for 100 rounds, and it's likely that the choices would converge to the Nash equilibrium, right? So although Nash equilibrium may not be a good prediction when we ask the participant to play the game for once, right, without any experience, but if you allow the experience to come into play, then it's likely that the behavior would actually eventually, in the long run, converge to the Nash equilibrium, right? So that's actually the concept of equilibrium, right? So when we talk about market equilibrium, where is the intersection between supply and demand, it may not be the case that the market would be always at the market equilibrium, right? But in the long run, if we allow players to learn from their experience, it's likely that the market will converge to the equilibrium, right? So that's why Nash equilibrium is actually an important concept for us to understand. Okay. Now, let's get back to this guess number game. How can we calculate the Nash equilibrium? Actually, the way to calculate is quite straightforward. Let me try to maybe write this. Let me see whether I can use a pen. Okay, so for the first one, so first forgive me the writing because I do not have a pen to write on. I have to write using the mouse. So for the first one, when 2/3 of the average is the winning number, how do we calculate the Nash equilibrium? You can actually just make this 2/3 of x equals x and solve this, right? So this meaning that if everyone is choosing x, then the target number is x, then no one would change their choice. So here you can derive that x is equals to 0. And for the second case, we can again equate 1.1x equals x. Let me see whether this will be the way to arrive at the answer. Here they can never be the same, right? So let me think. I mean, here I guess you need to say here there's a bound for x. It's between 0 and 100. So when you have an x average, the number will always be greater than x. So it will increase to the bound for it to be the target number. So when x equals 100, then even though everyone would want to increase this number to 110, but because the bound is 100, so you can actually say that the Nash equilibrium is 100. So this, I guess this equation will not work here for calculating this Nash equilibrium. But for the third case, when you have 100 minus 2/3 x, this you can calculate the Nash equilibrium by using this, by make these two equal, because if the answer is between 0 and 100, you can use this equation. So here x is, I guess it's 3/5 multiplied by 100, so that's 60. Okay. And you can calculate this. I mean, let me. Here, I'll just write down the number should be 60, right? So it's simple algebra. You calculate this, you should be able to see if it is 60, then this equation would hold. Right? So that's how you calculate this number. Because here, if everyone chooses 60, the target number is 60, and which is the same as 60, right? So this is actually this fixed point of this equation, and that gives rise to the Nash equilibrium, right? So this exercise would help you to understand how to calculate the Nash equilibrium, right? So the second case is a little bit complicated because, this number would actually, if it's a 1.1x, the number would always be greater than x. And we can reason that it should go over to the upper bound as for that to be the Nash equilibrium. But for the others, as long as it's between, as long as this solution to this equation is between 0 and 100 within this bound, then we can use this equation to arrive at the Nash equilibrium. So that's the concept of Nash equilibrium. Yes.
If you go back,
yeah,
isn't the problem with the second equation that like 0 should still be a viable solution there?
It is,
because but then you go from like taking that, okay, you could solve it, it is 0, then you look at the game, what would happen if everyone played 0? Okay, then if one person wanted to play, or if one person was a level 0 player, they would take a random number, and that would drive it higher and higher and higher to the point where, because it's the closest, you would end up having to say 100 because it's the highest possible.
Yeah. So 0, so the equation does not work because, I mean, if you calculate that, 0 is not a Nash equilibrium in this case, because if everyone choosing 0, I choose 1, then the correct answer, okay, yeah, it could be 0 if there are a lot of numbers. But if I choose, for example, everyone choose 100, choose 0, then I choose 100. It may drive up the answer significantly high enough so that 100 may be maybe the solution. So this is actually quite complicated, right? So if the number of players is large, then 0 could be a Nash equilibrium. For example, if there are only 3%, or if there are only 2% playing this game, then by choosing 0, I could actually deviate so that my number is actually the target number. Right? So here, the second one is not a good question to ask because it's a little bit complicated. But I probably would not ask this question in exam. But the third one is maybe a good illustration how to calculate that. Yes, Luis, go ahead.
Doesn't the second one, like, isn't the problem with the second one that you are not only playing with rational players? Because if you were only playing with rational players, you would probably get a 0. But because you have a level 0 player, 0 is not a rational decision.
You could claim that, but here the rational player could also choose 0 or 100. So if the number of players are large enough, is large enough. Right? So this is complicated. We are able to discuss more in after class, because suppose there's 100 player, right? So all of them choose 0. So then 0 is a Nash equilibrium because by me deviating, I deviate from 0 to 1. I mean, 1 point, the average is actually still close to 0. 1.1 of the average still close to 0. So no one want to deviate. But on the other hand, if the players are all choosing 100, no one would want to deviate either. Right? So here, that's make this second question more complicated. So there might be more than one Nash equilibrium. Does it make sense, Luis?
Yeah.
Okay. Yeah. So if you want, we can discuss more about it. Since this is a bit complicated, so it's not a good exam question. Maybe for calculating Nash equilibrium. because this is not a game theory class, it's a behavioral economics class. You need to understand the basic concept of Nash equilibrium, but I don't want to make this a complicated situation for you to calculate. So now you understand the concept of Nash equilibrium. Why do we want to study games and game theory? Because games are actually the models, and the game theory would help us to model strategic situation as simple games, and this would allow us to strip away irrelevant factors. Okay. And also, you could quickly draw parallels from one situation to another, and it informs us how to change the game for our benefit. Okay, so we will try to discuss some real-life situations which are models as a simple games. So all these games are actually played by you in the experiment yesterday, right? So, but let's just go through four major examples that could be summarized as games that you have played before. So the first example is price war. So here is the description of the situation. In July 1999, Sprint, which is a major mobile phone carrier in the United States, announced a nighttime long-distance rate of 5 cents per minute. So it's a very huge, very dramatic cut in the rate, in the price for using the mobile phone service. And then in August 1999, AT&T, which is a major competitor of Sprint, cut its long-distance rate to 7 cents per minute a day, every day for a monthly fee of $5.95. Okay, so again, this is a significant cut in the price for the product. But here you can consider it as a price war between these major competitors. But after the announcement of the price cut, both of the company's stock dropped significantly. So AT&T stock dropped by 4.7% at announcement, and Sprint fell 3.8%. So you see this price war between competitors, it actually hurt both of these competitors. But why do firms still engage in price wars, given that it makes both parties worse off? Okay, so this could be explained by a game. So this game can be represented as a payoff matrix. So the three important components of the game, you have the set of players. So here we have two firms, firm one and firm two, and also the set of strategies. Either firm will be able to set the price as high or as low. Okay, so we have high price, low price for firm one, and high price, low price for firm two. And then we have the payoff structure. We just denote and specify the corresponding payoffs for each combination of strategies. So if both firms would choose high price, it's actually good for both firms. Each of the firms would earn a collusion profit of $10 million. Okay, and if both firms would choose low price, meaning they are engaging in a price war, they significantly cut the price. But if one firm cut their price, it will actually attract some consumers or stealing some consumers from the competitors. But if both of the firms cut their price, I mean, the consumer would stay hold, right? So if they will not significantly steal the consumers from the customer from the competitor, and because of the price cut, that would significantly reduce their profit they could earn. So here, if both of these firms choose low price, they can only earn $5 million, right? And if one firm choose low price, the other firm choose high price, then the firm choose low price would be able to steal some customers. So that would significantly increase their profit, while that other firm would actually receive a significantly lower profit. Okay, so that's the specification of this payoff matrix. Okay, you can look at this payoff matrix. So this is a game that you played a similar game. So this is, I can tell you, is called a prisoner's dilemma, right? So you can see and try to understand what is the likely outcome for this game. Okay, think about it. But now let's just introduce another game or another business situation that can be understood by a game. So example 2 is the best price guarantee. Okay, so in the United States, a lot of companies, and actually including in Denmark, in the United States, including Best Buy, Walmart, Target Group, and the Staple Inn Corporation, are all pledging to match their rivals' in-store prices. Okay, you may be thinking that this best price guarantee, or the so-called price match, is a policy that benefits the customers. So I don't know whether you have gone to a Bauhaus, right? So Bauhaus has this really big sign of price match when you get into the store. So maybe thinking that, okay, these companies, okay, they have this cooperative social responsibility. They really consider the benefit of the consumers. But if you approach this business situation from a game theoretical point of view, it's actually one way to mitigate the price war. Okay, keep that in mind, and we will explain why. Now, the third example is about a QWERTY keyboard. The keyboard that you are using is called the QWERTY keyboard. So that's actually called or named by the first 6 letters appearing on the top left of your keyboard. So QWERTY keyboard is the keyboard that most people are using. So, you know, these QWERTY keyboards are actually not the most efficient and effective keyboards to be used. I mean, it was invented because back then, when the typewriters were invented, were coming into play, the first typewriters, the letters are actually organized alphabetically, right? So because it's organized alphabetically, it's actually easier to remember the layout of the keyboard and easier for you to type. I don't know whether you have wonders, the layout of the keyboards are not ordered by this alphabets, right? So if it's alphabetically ordered, it's much easier for you to learn. Now everyone, I think, is familiar with this keyboard. Is, you know, you can type it relatively fast, but it's actually quite difficult for any one of us to learn. So the original QWERTY keyboard was invented to actually solve an issue, a technical issue. You know, the typewriters, when they were typed too fast, the bars, or say the keys, would stick to each other, and you have to, you know, manually remove this sticky keys and in order to type again. Okay, so the original QWERTY keyboard was actually invented to slow down the speed of typing. Okay, so it was designed in 1978 by Christopher Scholz, and it just slow down the speed to avoid the keys to being stuck. Right? So you can definitely tell from this history of QWERTY keyboard is not the most efficient and effective keyboard there. Indeed, some research has shown that this so-called Dvorak keyboard is actually simpler and make faster typing. Okay, so if you're curious what this Dvorak keyboard is, a lot of the PCs and most of the PCs and the Mac, including the MacBook, allow you to change the layout of the keyboard from QWERTY to Dvorak. Right? So it has been shown that if you ask the professional typist to learn this Dvorak keyboard, they actually are able to type it faster. And so meaning that they are actually better keyboards compared to QWERTY. But why is the case that most of the keyboards, almost all the keyboard that you see or you use today are actually QWERTY keyboard? Okay, so this situation could be illustrated by a game. In particular, it could be illustrated by a coordination game. Right? So this is related to the idea of past experience and conventions are able to shape the equilibrium today, and that might not be the most efficient equilibrium. Now, the last example I want to show you is this 3DO interactive multiplayer. So the 3DO company created the first 32-bit CD-ROM video game architecture. Now I think it's 512 bits now for most of the games. So back then 32 is actually was very advanced. And 3DO company is the company who first invented and introduced this 32-bit CD-ROM video game architecture. And it was named as the product of the year by the Time magazine. And this company developed a series of specifications. So the business model of 3DO company is to license software houses to produce games and collect only $3 loyalty fee. And it also licenses hardware technology for free. So it allows all the hardware companies to use this architecture, this very, very advanced architecture, and it's for free. They can use them. And only when the software companies they try to develop software to be used, they need to pay this $3 royalty fee for each copy. But none of you, I don't think, have ever heard of a 3DO Interactive company, because even though it's named as the product of the year back in 1993, it's actually discontinued in late 1996, despite its cutting edge technology. Why is this the case? Right. So here again, it's actually can be understood using a coordination game. Okay. So that's the applications, the real life application of the games. Now let's just try to get into the games behind each business situation and help us understand what was going on in those situations so that we have developed more insight into these games. So the first type of game we want to introduce is the game of cooperation. And change this from pens to automatic to a pointer. So the game of cooperation, usually we just use, it's called the prisoner's dilemma, right? So what is cooperation? Cooperation means benefiting others at a personal cost, right? So think about the last time you heard the word or the phrase that thank you for your cooperation. Why they want to thank you? Because cooperation from you or being cooperative is actually you need to sacrifice a little bit of your personal convenience for the benefit of the general good. Right? So cooperation means just benefiting others at personal cost, even though the cost may be negligible, but usually that means you have to sacrifice a little bit of personal convenience in order to be cooperating with others. And cooperation can be modeled as a prisoner's dilemma. So prisoner's dilemma demonstrates why cooperation is hard to maintain, although it is mutually beneficial. So here is the original settings of prisoner's dilemma. So two prisoners held in separate cells for a serious crime committed, but the prosecutors only have the evidence to convict them for a minor offense. And the penalty for this minor offense is 1 year in jail. Right? And this serious crime committed actually could put them into the prison for 5 years. So now, in order to induce these prisoners to confess so that they have the evidence to convict them, each prisoner is actually held in a separate cell, right? So now the police actually have this divide and conquer strategy. So they actually approach each of these prisoners separately. So they were told that if only one prisoner confesses, then the confessor would go free and the other would receive 20 years in penalty, in jail as penalty. And if both confess, each would receive a sentence for 5 years. And of course, if none of them confess, they are only able to be put in prison for 1 year. Okay, so that's actually a good situation. Now, if we try to understand this as a game, we could formulate a payoff matrix for these two players, right? So we just consider the years served in prison as negative payoff. So we see that if both of them keep silent, they only would need to serve in the prison for 1 year, each of them. And if both of them would confess, then both of them would be put into prison for 5 years. If the prisoner decide to keep silent, meaning they are trying to cooperate or helping the other, and the other decide to confess, then the one who cooperated by keeping silent would be put in prison for 20 years and the other would just set free. Okay, so now we have the payoff matrix. Think about what the likely outcome would be in this game. I know some of you have already taken game theory, so this is probably the first game that was introduced in game theory. Right? So you know the Nash equilibrium is actually for both prisoner to confess. Right? So let's just have a reasoning, try to understand this game. So you see the best outcome for the two prisoners is for both of them to keep silence. Then they are able to get free after just 1 year in prison. Okay, so here is actually a good outcome for both players. But what are you likely to do if you are one of the prisoners? Okay, let's just assume that we are, okay, each of us is prisoner A, and we are trying to play this game against prisoner B. So let's try to think. If prisoner B decided to be silent, and if we are silent, we need to serve in the prison for 1 year. But if we confess, we are able to get free immediately. So it's very tempting for us to choose to confess, right? Because 1 year in prison, 1 year gone, 1 year of freedom is gone. Compared to set free immediately, it's very tempting for us to choose to be free. On the other hand, if the prisoner B decides to confess and you choose to keep silent, you will have to serve in prison for 20 years. Right? But on the other hand, if you also decide to confess, you only need to serve in the prison for 5 years. Okay, so that means regardless of what prisoner B would do, you would actually try to confess in order to maximize your payoff or in order to reduce the years you serve in prison. Okay, so here it means that you have a dominant strategy, meaning regardless of what the other player would do, it's actually best for you to choose to confess. Okay, and the same reasoning would apply for prisoner B. And now, if both players choose their dominant strategy to confess, then it will end up in this outcome. Each of these players would serve 5 years in prison. However, as we have mentioned, if both of them were able to choose to keep silent, they actually achieve this mutually beneficial outcome of serving only 1 year, but they are not able to reach this outcome if they care about their self-interest. Okay, so that's why it's called a dilemma. So the dilemma indicates that there's a conflict between personal interest and the social interest. Okay. So here, as I mentioned, to confess is the dominant strategy. One is better off by confessing no matter of what the opponent does. So the dominant strategy is just the best strategy regardless of what the opponent would do. Okay. So the prisoner dilemma demonstrates the difficulty to achieve cooperation, which is this cooperative outcome, even if it's mutually beneficial, because the self-interested player, when they consider their personal gains, they will decide not to cooperate. They will defect. They will confess in this case. So here, the only Nash equilibrium for this prisoner dilemma is for both players to confess. Okay. So let's just have a review of Nash equilibrium, or I have already give you the definition. So what is a Nash equilibrium? An equilibrium. What is an equilibrium? In an equilibrium, all competing influences are balanced. Right. So when you reach equilibrium, then no one would want to deviate. So there's no other forces that will induce you or motivate you to change your behavior. And once you are at the equilibrium, it stays there without any other sources. And Nash equilibrium captures a similar concept. So this Nash idea of Nash equilibrium is proposed by Nash. So we have introduced the story of Nash, and also his one page of a paper that actually laid the foundation, one of the foundations of the Nash game theory. Okay. So Nash equilibrium is just a set of strategies such that no player would have incentive to deviate, and any strategy in this set is the best response to other strategies. And so dominant strategies must be Nash equilibrium strategy, right? So if you are in a game where there is a dominant strategy, so that dominant strategy must be Nash equilibrium strategy. And also when the players play their dominant strategy, it would lead to the Nash equilibrium. So Nash equilibrium represents a plausible outcome. So it is a self-enforcing focal point. If one expects the other to choose its Nash equilibrium strategy, then both would choose the Nash equilibrium strategy. And also at Nash equilibrium, expectations equals outcome, and no one wants to change their behavior. So even though sometimes Nash equilibrium does not always predict the behavior, but it has a good feature that we need to understand it for each game. right? And also, as we have explained, if you allow learning experience, then it's likely that eventually the play would converge to Nash equilibrium. Okay, now let's look at this game, Prisoner's Dilemma, and see the experimental result. So you have played the game twice, okay, the same payoff matrix, but twice. One, you randomly match with a new player at the start of each round. And for the second time, you will play with the same player throughout the 10 rounds, okay? So let me see whether I have the payoff matrix here. Maybe let's, yeah, let's just keep in mind, this is a prisoner dilemma, right? So the only difference between these two games is that for the second play, you are interacting with the same opponents or the same partner throughout the 10 rounds. So what are some interesting observations across these two different conditions? You will see that the cooperation level, the level of cooperation of choosing this this mutually beneficial outcome is actually significantly higher compared to when you are matched with a new person each round. Okay, so to see this comparison, from another perspective, so here is actually the average first round cooperation. I mean, first round cooperation can be considered as a tendency to cooperate at the start of this whole interaction, right? So you see that the partner session, the partner condition, the first round cooperation is almost 80%, but for random condition, it's less than 10%. And if we consider the cooperation level of all round, again, we see this significant difference, okay? So these actually illustrate repeating interaction with the same player is actually could significantly increase cooperation level, okay? But one interesting pattern here that I want you to take a look at is in round 10, you see a significantly drop of this cooperation level. Why is that the case? Anyone, if you are still there? This is the last question, and after the question, we'll call it a day.
Well, in general, for the last question, the reason you corroborate on this, when you know your partner, because you both know that the next time, if you don't corroborate, they're probably not gonna, you're not gonna list all pay out. But on the last one, you know you're not gonna do it anymore, so you're just hoping they're gonna corroborate and you're getting more out of it. And both will most likely think that, so you end up not corroborating the last one because you know it doesn't have any consequences for the further corroboration since there's none.
Yeah, very nice explanation. That's Sebastian, right? So here you see that at the end of this game, so this is called the end game effect. So this effect is actually universally observed in the lab. So at the end of this interaction, it can be considered as the end of the world, right? So suppose you are in the end of the world, then I assume that no one would be cooperative anymore because, since tomorrow will end, what's the point of being nice to each other? I mean, everyone would go for it, go for their own. But of course, so social norm will also play some important role. We would also observe some people are still likely to cooperate. So here, these cooperation rate is not going all the way to zero. We still see that 20% of you are cooperating. But we do see that this level of cooperation at the end of the interaction is similar to a one-shot interaction, right? Because there's no future interactions, okay? So as we will explain in our next lecture, a good strategy in this repeated Christian dilemma is the so-called tit-for-tat strategy. So tit-for-tat strategy, you just start with cooperating and then copy the strategy or copy the actions of your partner in the previous round. So this is a good strategy because you can condition your actions on the other player's action, and you can punish your opponent when they are not cooperating with you by not cooperating next round, by defecting, right? But this tit-for-tat strategy will not be able to work at the end of the interaction because in the future, you cannot punish me anymore. So what's the point for me to cooperating with you, right? Unless there's some personal ethics. So that's why we observe this end game effect. Okay, so I guess we'll stop here. And I believe we need to spend another lecture on this behavioral game theory. So next Wednesday, we'll continue our discussion on game theory. And also, I said that we will determine the winners from the previous experiment by drawing the winning raffle tickets. But for the sake of time, I think I already go over the time by 4 minutes. So we will wait until next Wednesday to determine the winner. Okay. And thanks a lot for your attention today. And again, apologize, we have to have this online teaching, but next week, hopefully everything will go well. And for the rest of the semester, we have the physical teachings, because I do believe that physical teaching will be more effective for learning and also the absorption of the quiz-finding concept. Okay. Okay, thanks a lot for your attention. Let's call it for a day and enjoy the weekend. I'll see everyone next Wednesday. And if you have any questions, I'll stay here for another 5 minutes. And also I'm always available by email. Okay, yeah, thanks.
Thanks for today.